Today I want to introduce the history of the telescope. I will introduce it with 4 parts. First part is the first telescope, and then is the invention. That is the reflecting telescope, and the last one is cassegrain reflector. For the first telescope, the Descartes had said that by taking our sense of sight far beyond the realm of our forebears' imagination, this wonderful instrument, the telescope, opens the way to a deeper and more perfect understanding of nature. The first telescope was created in the Netherlands, probably by Hans Lippershey in 1608. This is a picture of the Lippershey and his telescope. It was a tube with lenses in it, but the lenses are heavy and expensive and tend to be bend different wavelengths of light differently, making distant images blurry. So this is Hans Lippershey and his telescope. And then is the inventions. Because the Hans Lippershey's telescope, Kepler, Galileo, and Christian Huygens are all use this telescope. Through and great effort, it is so revolutionary that Galileo was imprisoned for the knowledge of he obtained from it. So for the telescope inventions are created by the Galileo, improve his design in the following year and apply it to astronomy. In 1611, John Kepler described how a far more useful telescope could be made with a convex objective lens and a convex eyepiece lens. By 1655, astronomers such as Christian Huygens were used building powerful of widely telescope with combined eyepieces. And the first page is the Galileo and his telescope, and the second page is the Kepler's telescope. By the beginning of the 18th century, very long reflecting telescopes were rarely used anymore. Further increasing of power beginning in the middle of the 17th century from a new form of telescope, the reflecting telescope. And the reflecting telescope was created by the Galileos. So this is his pictures. This is the picture of Galileo, and these are the telescopes. Before his persecutions, Galileo was working on a new design for a new telescope, one that used mirrors instead of the lenses. Newton's reflecting rather than the reflecting telescope was the first of the kind, but it wasn't long before a more model. And then a new telescope was created, that is gas-green reflectors. The gas-green telescope with one parabolic primary mirrors reflecting onto a hyperbolic secondary mirrors hit into a curve. Rins Catterson published the design of his telescope in 60 and 68. It remains to this day pretty much the standards from the telescope to the Huygens. So this telescope is the standards of today's telescope and is also the standards of the Huygens. That's all. Thank you very much.
Hi everyone. Let me introduce the different kinds of the telescopes. There are 3 main kinds of telescope. First one is diffracting telescope. The second one is Newtonian telescope. The third one is Smith-Cassegrain telescopes. So, what is the refracting telescopes? A refracting telescope, also called a refractor, is a type of optical telescope that uses a lens as its objective to form an image, also referred to a dioptric telescope. The refracting telescope design was originally used in spyglasses and astronomical telescopes, but is also used for long-focus camera lenses. Although large refracting telescopes were very popular in the second half of the 19th century, for most research purposes, the refracting telescope has been surpassed by the reflecting telescope, which allows larger apertures. A fractal's magnification is calculated by dividing the focal length of the objective lens by that of the eyepiece. Refracting telescopes typically have a lens at the front, then a long tube, then an eyepiece or instrumentation at the rear, where the telescope view comes to focus. Originally, telescopes had an objective of one element, but a century later, two and even three element lenses were made. And here are also some details for the refracting telescope. A refracting telescope is a telescope that uses the principle of light refraction. The light comes from the object we see, and then it passes through the lenses of the telescope, concentrates on the focal point, and then shoots toward the eyepiece of the telescope to produce image ripples. The disadvantage of the refracting telescope is that it changes the color of light because light is composed of a spectrum, and each spectrum has its own specific wavelength, so that the light of various colors does not all produce the same refraction. The refracting telescope, the lens changes the pace of light through focusing, but not all colors of light waves will completely fall on the focal point of the telescope and may spread to other places, forming chromatic aberrations. Of course, a combination of refraction lenses can be used to change this phenomenon. So here are some examples for the refracting telescopes. And next, I will talk about the Newtonian telescope. The Newtonian telescope, also called the Newtonian reflector or just the Newtonian, is a type of reflecting telescope invented by the English scientist Newton. Using a concave primary mirror and a flat diagonal secondary mirror, Newton's first reflecting telescope was completed in 1968 and is the earliest known functional reflecting telescope. The Newtonian telescope's simple design has made it very popular with the amateur telescope makers. So for the advantage of the Newtonian telescope, first one is as with refraction and the reflex telescope, the cost of the same aperture is the lowest because the production cost of a large aperture mirror is much lower than that of a lens. Because the focal radius is generally short, it is easier to obtain a larger field of view and has better observation performance of weak deep sky objects. Thirdly, Newtonian telescope with long focal lengths can obtain excellent planetary appearance and have good observation performance of the moon and the planets. Fourth is, since the reflector is used as the main mirror, there is no chromatic aberration. So for the disadvantage, firstly is generally not suitable for ground application, and secondly is the calibration of the Newtonian reflector is a problem. The calibration of the primary and the secondary mirror will deviate due to the vibration during transportation and operation, which means that the telescope may need to be calibrated before each use. And the next page is some example for Newtonian telescope. So you will look at there are all the reflector telescopes. So next page is the Smith-Cassegrain telescope. The Smith Cassegrain telescope is a catadioptric telescope that combines Cassegrain reflectors optical paste with a Smith character plate to make a compact astronomical instrument that uses simple spherical surface. Here is the function for the Schmidt-Cassegrain telescopes. For the Schmidt-Cassegrain telescopes, larger terminal equipment can be placed at the focal point of the Cassegrain telescope, which does not block the light, and the observation operation is more convenient. For a telescope with a primary focus system, a Cassegrain system, and a folding axis system, the relative aperture of the Cassegrain telescopes is medium. It is suitable for medium power, large scale photography and other tasks. The main work carried out here includes spectronic corporal observation of a larger spectrometer, direct photography and image intensifier photography, and photoelectric photometry and infrared observation. Here are some examples for the Smith Cassegrain telescope.
My name is Atika binti Kamazaman and I will explain about the ray diagrams for telescope. First, we are going to look into our first ray diagram, which is refracting telescope. Refracting telescope is the most basic ray diagram for a telescope. There are actually some different ray diagrams for telescopes in which they use mirrors or erecting lens. For the first case, I will explain about a ray diagram which uses two converging lenses or two convex lenses. There are two parts. The first ray diagram is through the objective lens and the second part is through the eyepiece lens. We will go through each part in details. First, light rays from the object at infinity will be directed to the objective lens. As usual, by using three laws of ray diagram, we can sketch our diagram properly. But take note that as the object is at infinity, the ray coming from the object will be parallel to each other as the distance is very far from the objective lens. As we draw the ray refracted from the objective lens, we can see that the image will form at the back of the lens or at the opposite side of the lens. The distance of the image from objective lens is the same as the focal length of the objective lens, while the distance of the image from the eyepiece lens is the same as the focal length of the eyepiece lens. As for the second part, we take the image formed as the object for the eyepiece lens. We do the same by using the laws of ray diagram, but we can see that the light rays do not converge with each other. So we draw another light rays at the other side. We can see that they are converging at some point at the end. So that is where the final image will be formed. Next, we are going to look into the ray diagram for astronomical telescope. First thing first, notice that instead of using two lenses, this telescope actually uses a concave mirror as the objective mirror, one flat mirror as the secondary mirror, and a convex lens as the eyepiece. This type of telescopes needs to gather as much light as possible, so mirrors are used instead of lenses because they can be made with much larger and more precision. First, light rays from the distant object will be directed to the objective mirror. As I have mentioned before, distant object resulting in parallel rays. The rays will then be reflected onto the secondary mirror. The mirror will reflect the rays to the eyepiece lens. The rays coming out from the lens will form the final image of the distant object. Just now I had explained the first type of ray diagram in astronomical telescope. For this part, I will share the second type of ray diagram. The only difference between these two types is the organization of the lens and mirror. First, as usual, the light rays from distant object will be directed to the objective mirror. Then the mirror will reflect the light onto the secondary mirror. As we can see here, the secondary mirror is placed in a straight line. Hence, the reflected rays will be directed towards the path in between the objective mirror onto the eyepiece. Finally, the rays coming out from the lens will form an image of the distant object. Last but not least, I will explain about the ray diagram for terrestrial telescope. For your information, we have two different types of terrestrial telescope. The first one that I'm going to discuss is Galilean type. As we can see here, Galilean type will use one convex lens as the objective lens and one concave lens as the eyepiece. First, rays from distant object will enter the objective lens. The rays will be refracted onto the eyepiece. Then, the eyepiece will diverge the rays to form an image. But as we can see, the rays do not converge to a solid point. So we will draw another light rays at the other side, and we can see that the rays finally converge at the left side of the objective lens. So that is where the final image will be formed. The second part for our terrestrial telescope is spyglass. There is a major difference from the first type, which is this telescope actually uses three converging lenses. There are three parts, which are objective lens, second lens, and eyepiece lens. First, light rays from the distant object will go through the objective lens. The lens will refract the light to form an image at the opposite side of the lens. The distance of this image to the objective lens is the same as the focal length of the objective lens. For the second part, we will use the first image as the object. The rays will be refracted by the second lens to form a second image in between the eyepiece and the second lens. For the third part, we use the same method. We take the second image as our object, and then the eyepiece will refract the light rays into our eyes. But the rays do not meet at the same point. So we draw another light rays at the other side. We can form the final image in between the objective lens and the second lens. So that is all the ray diagrams for different types of telescopes. I hope you can understand roughly how the telescope works.
First is principle of the refracting telescope. There are two lenses in refracting telescope, which are objective lens and eyepiece lens. Both of lenses is convex lens. It uses law of refraction of light to make an image of the actual object and magnifies it so that it is visible to the observer. Refracting telescope is used to watch planets and moon. As I mentioned just now, there are two lenses in refracting telescope, which are objective lens and eyepiece lens. For the objective lens, it is located in front of the refracting telescope. It collects the light ray from the focus object and magnifies it. It has larger size length, so it can gather more light. It has long focal length, so it can magnify the object. For the eyepiece lens, it is used for regulating the magnification of the telescope. It has smaller size lens compared to the objective lens, and also it has shorter focal length compared to the objective lens. The advantages of refracting telescope. First, it is very easy to use because of its simple construction and working mechanism. Second, it has only two lenses, so it barely any chance of misalignment once we have aligned it. Third, it's popular among stargazing. Fourth, the glass surface inside the tube is sealed from the atmosphere, so it rarely needs cleaning. Fifth, since the tube is closed off from the outside, air currents and effect due to changing temperatures are eliminated. This means that images are steadier and sharper than those from a reflector telescope of the same size. And last one, refractor telescopes are rough. After the initial alignment, their optical system is more resistant to the misalignment than the refractor telescope. The disadvantages of refracting telescope. All refractors suffer from an effect called chromatic aberration that produces a rainbow of colors around the image. Because of the wave nature of light, the longer the wavelength of light is bent less than the shorter wavelength of light as it passes through the line. This is used in prism to produce pretty rainbows, but it can ruin an image. Second is the light passes through the lens varies with the wavelength of the light. Ultraviolet light does not pass through the lens at all. Third, the light passes through decreases as the thickness of the lens increases. Fourth, it is difficult to make a glass lens with no imperfection inside the lens and with a perfect curvature of both sides of the lens. Next, I will present the principle of Newtonian telescope, or known as reflecting telescope. Angle of incidence is equal to angle of reflection. The angle of incidence is measured from the perpendicular to the reflecting surface is equal to the angle of reflection. The largest optical telescope are reflecting rather than refracting telescope. For technical reasons, the largest optical telescope are reflecting rather than refracting telescope. It is easier to build and support large mirrors of high optical quality than large lenses. Focus for reflecting telescope. One problem that must be considered with a reflecting telescope is how to place an observer at the focus. In the example shown above, the focus is inside the telescope. This is called the prime focus, and in some large telescopes, observation can be made at the prime focus. More commonly, various mirror arrangements are used to transport the light from the focus to an external observer. Two common ones are a Cassegrain focus and Newtonian focus. There are three powers of telescope. First, collecting area. Second, resolution. Third, magnification. First, collecting area. It makes the image brighter. Light gather power describes how much light a telescope can collect. Second, resolution. It makes image more detailed. The second power of telescope is the resolving power. This describes how effectively a telescope can measure fine detail. Since light acts as a wave, as described earlier, it produces a diffraction fringe around each point in the image, and we cannot see any detail smaller than the fringe. The larger a telescope, the smaller the fringe, the better the resolving power. The resolving power is proportional to the wavelength divided by the telescope diameter. Third is magnification. Magnification is the ability of the telescope to make the image larger. It is determined by the ratio of the focal length of the objective to the focal length of eyepiece, which is m equal to FO over FE. This is least important power because stronger magnification does not mean more detail, since the detail is limited by the seeing and the amount of light. Thus, if you magnify something which is unresolved, you just get something larger which is also unresolved. If you buy a telescope, buy a reflecting telescope with good optics, good mount, and largest collecting area possible. Do not worry about magnification power. The advantages of Newtonian telescope. First, the reason that Newton created the telescope was because of the lens problem, which is chromatic aberration. So that is the biggest advantage for the reflector telescope or Newtonian telescope. There will not be a ring of color around objects. They are viewed with this kind of mirror design. Second, the quality of the mirrors will influence the image quality. The aperture ratio is a component of the Newtonian style telescope that you will have to consider when you are researching your purchase. Third, the aperture ratio is calculated using the focal length of the telescope in its aperture. If the telescope is 100 over 1000 mm, there is an aperture ratio of f over 10. These types of reflecting telescope have a huge range of apertures and aperture ratios. Fourth, the Newtonian telescope can be designed with a focal ratio that allows astronomers to see clearer because more light is allowed into the telescope itself. Fifth, the reflecting telescope has a wide range of apertures for a reasonable price. They are often less expensive than the refracting telescope. That is one of the biggest advantages that new astronomers want to consider. And the last one is the mirror will give you a great view of objects in the sky without the rings of color seen in refracting telescope. The disadvantages of Newtonian telescope. First, the secondary mirror can produce shadows. There might be an obstruction of light to the secondary mirror versus how much actually enters into the tube. A refracting telescope doesn't have that concern because there is nothing obstructing the beam of the light. Second, the mirrors have to be aligned occasionally too. This is not a concern for most experienced owners, but new astronomers might be intimidated by the thought of having to align mirrors in their telescope. Principle of Schmidt-Cassegrain telescope. First, the Schmidt-Cassegrain is a catadioptric telescope that combines a Cassegrain reflector's optical path with a Schmidt corrector plate to make a compact astronomical instrument that uses simple spherical surfaces. Second, the Cassegrain telescope is an astronomical reflecting telescope in which the light is incident on a large concave parabolic mirror and reflected onto a smaller convex hyperbolic mirror. This reflected light is reflected again through a hole in the concave mirror to finally form the image. Third, the reflecting principle used in the working of this telescope is incorporated in most modern optical telescopes. Cassegrain designs are also used in the construction of satellite communication systems, such as Earth Station and radio telescope. Fourth, the classic Cassegrain telescope consists of a parabolic reflector, which is a primary mirror, and a hyperbolic mirror, which is secondary mirror. The parabolic shape of the mirror helps in gathering light, similar to the way that a refractors gather light using an objective lens. Fifth, the hyperbolic secondary mirror reflects light such that it is focused onto the hole in the primary mirror. And the last one, the eyepiece and the other instruments are located behind the telescope. The folded optical path in this telescope makes it compact and portable. Advantages of Schmidt-Cassegrain telescope. First, Schmidt-Cassegrain are high-level all-purpose telescope, ideal for viewing the moon, planets, and deep sky objects. They are also ideal for astrophotography using everyday DSLR cameras. Most come with computerized go-to mounts and motorized object tracking. The corrector plate of the Schmidt-Cassegrain telescope is an aspheric lens. It allows having big apertures because the lens plate is thin and easier to manufacture. This also adds another advantage of requiring less time for the whole telescope to thermally equalize to the outside temperature on your viewing side. Its secondary mirror, on the other hand, allows this telescope to be free of diffraction spike. Another advantage of this telescope is with its collimation. Its collimation tends to be solid, which means it does not require repeated collimation often at all or throughout the night. The disadvantages of Schmidt-Cassegrain telescope. First, a catadioptric telescope becomes heavier rather quickly as they increase in aperture. Second, it requires more frequent optical alignment when compared to refractors. Third, a catadioptric telescope moving parts are more complex than those found in a refractor or reflector telescope. Fourth, catadioptric telescopes have an inherent optical performance limitation based on the second obscuration of their aperture caused by their own secondary mirror. However, classical Cassegrain and Newtonian reflecting telescopes share this problem. The limitation is very subtle, so most amateur astronomers do not even notice or care about this detail. And the last one is The picture is less sharp than a reflector telescope.
Hello, my name is Liu Zheyu. Metric number is 195783, and I will teach you how to make telescope at home. We need some materials first. There must be 2 magnifying glasses and an empty cylindrical box. You can take the empty badminton box. And we need foam board, mark pen, paper knife, glue, and the cardboard, also a hard paper, which we will be using later. First, we take out 2 magnifying glasses, and you can take it from the magnifying glass that you use to watch. And step 2, we draw a circle on foam board using the badminton box. We put the badminton box with bottom against the foam board, and same time we draw the circle with the bottom circle corresponded, and we cut this circle out. We will get an area which is showing this picture. And next step, we draw a small circle on the cutted foam board using a small glass. The length of the circle is same as the arc length of the small glass. And we also cut this area out. We will get a large circle like this. In next step, we're using glue to stick a cylindrical hard paper. First, we screw this paper a cylindrical shape, and we use glue to snap it, to stick it. And then we also use glue to stick small glass on the bottom of the cylindrical paper. And now we put the cutted circle of foam board on this cylindrical paper. We stick it, and I also cut out a cardboard and also stick it on this cylindrical paper. From now, we finish the one item, which is important part of the telescope. And in step 6, we make another atom. And we're using glue to stick the large glass on cylindrical box. And we use the badminton box. First, we give some glue on the bottom of the circle of the badminton box, and we put large glass on it. Now we finish the 2 items and we combine them together. We put the small one into the badminton box, and it will be stuck at the top of the badminton box. And now we can use any cover paper you want to this badminton box. Now we complete this telescope. You can use it in either direction. Okay, that's all. And thank you.